Hello, in this video we are going to see what is the importance of circular polarized antenna and how we can achieve the circular polarization. So we usually have seen these type of truncated patch antennas which are used for the circular polarization. Circularly polarized antennas are very important for the satellite communications because in satellite communication we know that wave has to propagate through the atmosphere and atmosphere will cause the Faraday rotation. So these circular polarized waves are very reluctant to the Faraday rotation, and that's why these circular polarized antennas are widely used for GPS and GNSS applications. So let's see how we can achieve the circular polarization. In case of the linear polarization, this will be the expression for the electric field. It will be having either X component or Y component. In this case, we can see that it has only the Y component and it is changing on the vertical axis. This is a case of linearly polarized wave. So in case of our rectangular patch antenna, when we design the patch antenna, we know that the length and width will be different, and these are the design equation for designing a rectangular patch antenna. When we observe the current distribution, we can see that the currents are changing as in the case of a linearly polarized wave. Here you can see that this variation is happening up and down as in the case of these things that we are seeing here. So when we see this case, we can see that the electric field will be varying along this y-axis. That is the same case that we are seeing in case of these rectangular patch antenna. But in the case of a circular polarization, we know that it will be having both X component and Y component. And this will be the variation of the electric field. And we know that this will be the propagation. If you want to know more about these linear and circular polarization, we have videos in our channel to get more ideas. So in case of the right hand circularly polarization, these waves will be rotating like this, and we can see here that it will be having Ex component and Ey component. When you see the magnitude, which is E0, that will be the same for both, and you can see the phase difference. So one is in the cosine and one is in the sine domain. So there is a phase difference of 90° between these two components. That are the condition for the circular polarization. That means that it has the same magnitude, but it has also has to be having a phase difference of 90°. So let's see how we can achieve the circular polarization from the antennas. So if we want to achieve the circular polarization in antenna, as we seen earlier, it should have two orthogonal electric field components, and they have equal magnitude and they have 90° phase. That is what we have seen here. So we can achieve the circular polarization from an antenna by adjusting the physical dimension of the patch or either by using single or multiple feeds. Let's see how we can achieve the circular polarization in case of a patch antenna. So first one is single feed method. So in this case, the modifications are done on the patches. So first one is truncated corner microstrip antenna. So in this case, we are going to use a square patch. Having square patch means both length and width will be the same, and the feed is as in the case of a normal prop fed rectangular patch antenna, and we are providing truncation at the ends. So based on the position of the truncation, it can provide right hand circularly polarized wave, and if the truncation is on the opposite side, it can provide other circular polarization. Circular polarization can also be achieved by using some slots in the patches. So the use of truncation and the slot in the patches is done such that it will be causing some length difference along the diagonal. So here in this case, you can see that if you consider this diagonal and this diagonal, because of this truncation, length of this diagonal is different from length of this diagonal. So this asymmetry is providing the circular polarization. So here also we are using some asymmetry to get the circular polarization. Other antennas are these type of spiral antennas. This type of this is helical antenna. This is helical antennas, and we can see some types of spiral antennas for providing the circular polarization. Another method is if we can feed the antenna at this corner, it can also provide the circular polarization. In all these cases, length and width has to be the same. If we are considering the circular patch antennas. Another method is because we have seen previously that if we have to obtain the circular polarization, it will be having EX and EY component, and there should be a phase difference of 90 degree. So we can obtain that by using dual feed method. So we can feed the patch at using two feed points, and the phase difference between these two feed has to be 90 degree. So in case of if we consider the wave, so the total wave is lambda, and if we consider lambda by 4 here, this will corresponds to 90 degree because this total corresponds to 360 degree, and here corresponds to 180 degree, and up to lambda by 4 means 90 degree phase difference. So if we can provide a 90 degree phase difference between these two feeds, we can also obtain the circular polarization. So if we get the circular polarization, here you can see that how the surface current is varying. So it will be getting rotated like this. You can see how the surface current is getting rotated, as we have seen in the case of the wave propagation in earlier slide. So this is how we are achieving the circular polarization. So here you can see that the truncation is at these positions, and if we are going to truncate here, we can get the rotation in other direction, so we can get the right hand circularly polarization. So in a coming video we can see how we can design a truncated circular patch antenna, truncated uh, we can design a patch antenna with truncation, and how we can obtain the right hand and left hand circular polarization. So one of the important characteristics of the circular polarized antenna is axial ratio, because we have to make sure that the EX and EY component has the same magnitude. So to ensure that, we are using the parameter axial ratio. So if we plot the polarization, that is the variation of the EX and EY field, we will be getting a polarization ellipse. So in case of the circular polarization, these major axis and minor axis will be the same. That means that this ratio will be equal to 1. That is what we are seeing here. That means that both EX component and EY component will be the same, and we will be getting the axial ratio of 1. So if we convert that into dB, it will be corresponding to 0 dB. So in our actual cases, we are considering, in case of an axial ratio is less than 3 dB, we can consider it as a circularly polarized wave. So this is one of the important parameters that we have to consider while designing the circular polarized antennas. So this factor gives us an indication that both EX and EY component have the same magnitude. Okay, so in our next video, we can see how you can design a right-hand circularly polarized antenna. So I hope you get some idea about what is meant by the circular polarization and how we can obtain that. Thank you.